Okay, so let's solve this question. As we already know that the finely divided catalyst is more efficient. So in this problem, we are given with that for catalyzed action, a total surface area of 6291456 centimeter square is required for absorption of gases. So we have to find the number of slits which should in which a cube should be cut to get exactly 1 centimeter in length.
Right. So this is a very good question. Actually, it employs the use of logic with mathematics. Okay. So we'll see how. So I'm given a cube of length 1 centimeters, right?
Okay.
Now, if I take each side of the cube and split into 2 halves, like, you know, there will be 3 planes. One will be this, the other will be this, and the other will be this.
Okay.
Okay. Then I will get, if you visualize, you will get
8 small cubes.
8 small cubes, right?
Exactly.
Right. 8 small cubes and their sides will be 0.5 centimeters.
Exactly.
Right. I am starting with a cube of 1. Right.
So the side length of smaller cube will be 0.5 centimeter.
Right. So let me, okay, fine. I'll name this as L is equals to 1 centimeters. This is the side of the bigger cube, and side of each smaller cube will be 0.5 centimeters in length.
Okay.
Now, when I take the bigger cube, the cube of side 1 centimeter, the surface area of one cube will be L square.
Exactly.
So it will be 6 into 1, which will be 6 centimeter square. Now, right. So the surface area, now if I divide one big cube into 8 small cubes, the new surface area will be how much? 8. There are 8 cubes into the surface area of each cube, which will be 6. So it will be 8 into 6 into half, which will be 12 centimeters square.
Okay, so it has increased.
It has increased, obviously, which is quite obvious, right?
Yes.
Yeah. So what do I get by this? Each time, okay, each time if I divide a side by 2, we get 8 new cubes.
Yes.
So like I have a cube, I divide this each side by 2, I get 8 cubes. Now in those 8 cubes, I repeat the same operation.
Okay.
So every time this operation is repeated for a cube,
the surface area is doubled.
The surface area is doubled and I get 8 new cubes.
Yes.
Right. So after n splits are made,
okay,
what will happen? I will get the total surface area as 8 raised to the power n. This will be the total number of cubes, and 6 into half raised to the power n. Right?
Yes.
Yeah. So this will be 2 raised to the power n into 6. I can simplify it.
Yes.
Because it will be 4 raised to the power n. So yeah. So now I know this total surface area required is given to me as 6291456 centimeter square.
Yes.
And I need to find out the number of splits.
Okay.
So I can solve this easily. It will be n raised to the power 20. It obviously requires the use of a calculator.
Okay.
Because solving it manually can be very time taking, right?
Exactly.
So 20 splits should be made in a cube of length 1 centimeter to obtain this much area.
Okay. So by this we end this question. Okay, so let's solve this question. The question says that the density of gold is 19 gram per cc. If 1.9 into 10 to the power minus 4 grams of gold is dispersed in 1 liter of water having spherical gold particles of radius 10 nanometer, then we have to find the number of gold particles present per millimeter cube of the solution.
Yeah, so in this question we'll be using basic mathematics to get the answer.
Okay.
In the question I've been given the density of the gold salt, right?
Which is 19 gram
9
per
gram
cc.
per cc. And the weight is also given, right? The mass is given as 1.9 into 10 raised to the power minus 4 grams. So I can find out the volume of the gold salt, right?
Yes.
Volume of gold in the salt.
Yes.
So it will be 1.9 into 10 raised to the power minus 4 upon 19, which is 10 raised to the power minus 5 centimeter cube.
Yes.
Right. So this is the volume of gold dispersed in 1 liter of water.
Yes.
Right. Now, the radius of the gold particles, is given as 10 nanometer,
Yes.
which can be written as 10 into 10 raised to the minus 9 meters.
Right.
Or if I want to convert it into centimeters, then I'll multiply it by 100.
Okay.
So I'll get 10 raised to the minus 6 centimeters.
Yes.
Right. Now, if I know the radius, I can calculate the volume of one gold particle.
Yes.
Yeah.
Usually 4 by 3 pi r cube.
Right. 4 by 3 pi r cube. If I substitute 4 by 3 into 22 by 7 into 10 raised to the minus 6 cube centimeter cube.
Okay.
Right. So if I calculate this, I will obtain 4.19 into 10 raised to the minus 18 centimeter cube.
Okay.
Right, this is volume of one gold particle.
Yes.
Now, I know that this much, as in 10 raised to the minus 5 centimeter cube, how many gold particles are present? I can calculate that.
Yes.
Number of gold particles
In 10 to the power minus 5 centimeter cube.
will be 10 raised to the minus 5 centimeter cube into volume of one gold particle, which we just calculated as this.
Exactly.
Right? So we will get 2.38 into 10 raised to the power 12. This is the number of gold particles in 10 raised to the minus 5 centimeter cube.
Okay.
Now I need to find the number of gold particles in 1 millimeter cube.
Okay.
Right? Which will be 2.38 into 10 raised to the power 12 into 1 millimeter cube upon 10 raised to the power minus 5 centimeter cube.
Yes.
I can convert centimeter cube into millimeter cube
Yes.
by
Because we know that 1 centimeter is equal to 10 millimeter.
exactly. So I will just multiply this by 1000
Exactly.
and get millimeter cube. This will cancel. Now I can easily solve this. This will be 2.38 into 10 raised to the power 14.
Okay.
Right.
So this much
So-
gold particles are present in 1 millimeter cube of the solution.
Right.
Okay. So by this we end this question. So let's solve this question. In this question we are given with this plot and we have to find, and we are also given that the pressure is 0.5 atm. And the question says that we have to find the amount of solute absorbed per gram of absorbent per gram of absorbent.
Right. So as I mentioned earlier also that the isotherms in this question are quite important. Questions will be based on them, as in if a question is asked, it will be mostly in this from this topic, right?
Okay.
So yeah, let's see the Freundlich adsorption isotherm equation. It is something like this. We should memorize this, right?
Yes.
Yeah. Now the slope, if I write this in the logarithm form, it is log of right?
Log of p.
Yeah, log of p. So the slope is given by 1 by n, which in this case is tan 45,
Which is 1.
which is 1. So n is 1, and k is given to me
Is
in the
given
question.
in the question.
Yeah, it is 10, right? So I know that x by m is equals to 10 into p raised to the power 1, which is 10 into pressure,
Okay.
right? Now what do I need to find? Now pressure is given to me as 0.5 atm,
Okay.
right? So I can simply substitute it in this equation and I'll get 5. So I had to find out the value of x by m, which is 5.
Okay. So in this question we just applied this equation and got our answer. So let's solve this problem. The question says that 50 ml of 1 mole oxalic acid is shaken with 0.5 grams of wood charcoal. The final concentration of solution is given to be 0.5 molar. You have to find the amount of oxalic acid absorbed per gram of carbon.
Right. So let's start solving this question. We are given 1 molar oxalic acid solution initially,
Okay.
50 ml, right? And we know that in 1 molar solution what does it mean? 1 molar solution means there is 1 mole of oxalic acid in
1 liter
1
of the
liter
solution.
of the solution. Right.
Yes.
Right. So now, see, okay, so 50 ml of 1 molar oxalic acid, I know that 50 millimoles will be present,
Yes.
right? 50 millimoles, or you can say 0.05 moles.
Moles.
Right. Okay. Now I need to know the molecular weight to solve this question, because I am asked the amount of oxalic acid. So
And it's also not given in the question.
it's not given in the question. So molecular weight. So mostly in questions like these, you're not expected to remember the chemical formula
Yes.
of oxalic acid. So either you'll be given the formula,
And don't worry, JEE always gives molecular formula.
right, or you'll be given the molecular weight directly. And the molecular weight can be calculated as 126 gram per mole.
Okay.
Right. So I know now that the initial mass of oxalic acid is 0.05 moles into 126 grams per mole,
Right.
which is 6.3 grams. Right?
Okay.
Now, see, I need to find out the amount of oxalic acid adsorbed per gram of carbon. And I know the weight of carbon also. It is 0.5 gram wood
Yes.
charcoal, right? So I just need to find out the difference in the mass of oxalic acid finally and initially.
Yes.
Right. So finally I know that my solution contains 50 ml of 0.5 molar oxalic acid, which means 50 into 0.5 millimoles or 25 millimoles.
Okay.
I can write this as 0.025 moles, and in terms of weight, I'll just if I want to find out the final mass of oxalic acid, I'll just take the number of moles and multiply it by the molecular weight. So I will get 3.15 grams.
Okay.
So now I know the initial and the final masses. So the change in mass of oxalic acid is 6.3 minus 3.15,
Grams.
which is 3.15 grams.
Okay.
Right? So yeah, I need to find out the amount of oxalic acid adsorbed per unit weight of carbon.
Yes.
So it is 3.15 grams upon 0.5 grams charcoal or carbon. So if we calculate this, this will come out to be 6.3 gram of oxalic acid per gram of
Charcoal.
charcoal.
Okay. So by this we end this question.